Hey guys, welcome to Let's Talk Algorithms. This is Venkatesh, and today we'll be solving the problem decode ways. Let's look at the problem statement. A message containing letters A to Z is being encoded to numbers using the following mapping. It's basically the character to the respective digit from A to Z. So if you are given an input, a string basically which contains digits like 12 in string form, and you get the output 2. Why? Because 12 could be decoded as AB, which is like 1 and 2, or 12. 12 is L. So let's look at the given input. Let's form a workbook. AB is, so if you were given 12, its output is 2 because 1 comma 2 and 12. And if you're given the input 2 to 6, output is 3 because 2 comma 26, 26 is valid, 22 comma 6, and 2 to 6. All right, so basically given a string containing digits, find out how many ways you could represent that in terms of alphabets, like the respective mapping. So plenty of the solutions you see elsewhere use dynamic programming will use the similar approach. So the crux of the solution is basically finding out the number of ways you could decode a string at each index. Like basically, let's write a small algorithm, find out number of ways to decode at each index, return the last index value, right? That's what you're gonna do. So when I say this algorithm, let's start with again 1, 2. Um, you start with example. Let's say you look at the number of ways the string at 1 could be resolved is basically 1, right? How you do that? So what is valid string though, right? Like valid string is anything from 1 to 26, right? So there is two ways to check. Since the max value is 26, um, you could only consider two digits at a time. Two digits at a time is a valid string, or less than two, which is basically one. So you can not count three digits anymore. So what happens is like when you have something like 12, so at each digit you can check if the digit is 1. If not, or if digit is 2 and last digit is basically if digit is 2 and basically next digit is less than 7, right? So these are the only values, right? If it is either basically 1 or if it starts with 2 but ends below 7, which is basically 6. So these are valid digits. So if a single digit is valid, you add 1 to the result. If a two-digit number is valid or a string is valid, you add 2, or basically the last two values. Add last two values. So if you're looking at dp, it's basically dp of I is equal to dp of I minus 1, or dp of I is equal to dp of I minus 1 plus dp of I minus 2, depending on whether it's a one digit or two digit. This is the recurrence relation. So instead of using actually um, an extra space, an array which to store all your dynamic programming values, you could just, what we are actually looking at the end of the day is basically two values, right? The last two digits, two strings value. So we instead you could just have something like x comma y resembling the last two digit values. So you could have two variables basically storing these values and get away by using constant space instead of using an array. So let's start with the code. Let's, you always can start with short circuit exit conditions, negative conditions. If length of s is equal to 0, or if a string starts with 0, that means it's not valid, right? Like you can see as 1 to 26. So 0 is invalid. If it's either of the cases, return 0. And let's have two variables. Let's call it a comma b. Assign them to 1. Why 1? Because imagine you starting with an empty string. So the number of ways you can decode an empty string is 1, right? So let I equal to 1, typical loop, length of s, I plus plus. So the first condition you would check is if s of I is equal to 0. If it is 0, then you basically say a equal to 0. Then the next condition you could check is if s of I minus 1 is equal to 1, or s of I minus 1 is equal to basically the characters, and s of I less than 7. So if these are the two cases, and to be clear, you could just write equal to 6. So 1 to 26. If you have either of the things, then you can just basically add the last two values, a and b, and then you can assign b a minus b. If this condition doesn't satisfy, you can just basically assign the value b, assign the a value to b. And finally, you basically return the last value, right? Length of s, which is basically a. So let's run the code. All right, it works for 1, 2. Let's check for 2 to 6. Works great. Let's check for some negative conditions. If we start with 0, you know what should the output be? 0. Because anything which starts with 0 is invalid. Let's say you have something called 206. Guess the result for this. It's 1. Because the only way you can decode is, this is basically 20 and 6, right? 206 is 20 and 6. Because 2 and 06 is not valid, and 206 are not valid. All right. If you have any questions, please feel free to post a comment. And if you like the solution and if you want to keep this kind of videos coming to this channel, please subscribe. Thank you so much.